It should be hasn't been anymore. Who? Oh, no, it's fun. I didn't even notice. I knew there was a blank desk, but then I was thinking Christine's over there, Joe's over there. Noah's here. Okay. Let's go ahead and grade for them and for you guys, because we have not looked at the evens of section 5.5. Remember, I did cross out some of these, so we're going to ignore number 10, right? We're going to ignore number 10, even though I guess you could have done him without the property, I was thinking. You could have used the double angle property instead. Maybe I should have left number 10. Anyway, we can peek at number 10 because some of you guys already tried it. The double angle property was actually sufficient, and then factoring. See, I was thinking that you were going to use the sum to product formula, but I guess you didn't have to. And then the other two I skipped, help me out real fast. Is it 42, 49? Were those the other two that we skipped? 49 and 62. Ah, thank you. 49 and 62. So let's go ahead and start with number 2. It was just filling in formulas, and yes, there were 3 different variations, as you guys saw on your version of the quiz. Number 10, I let you guys go ahead and skip, but once again, if you want to peek up here just real fast, you could have used the double angle formula. You could have used the double angle formula for cosine and then factored and not had to use those formulas that we crossed out, so there was another way to change. It would have been possible actually with the old formulas, getting down to the unit circle. But you could have skipped that one, so let's go to number 20. Number 20, there is no 10 in a formula, but you could pull out the common 5, and all of a sudden, is there a 2 sine squared x minus 1 formula? And the answer is a definitive yes, it's the double angle of cosine. So this t-proof, you could have factored out the 5, chosen this side, factored out the 5, and replaced with the double angle of cosine formula. So remember, guys, even though there are numbers and those don't match your formulas, factor, and then maybe something will match your formula you can plug in. The only extra step is they had to also pull out a negative because the signs were backwards. Pull out a negative, then you can substitute. Number 22 was a given a ratio. Fill in the phrase, given a ratio, make a triangle. It was a make a triangle problem. It was a make a triangle problem. So they gave you a clue. You should have labeled your adjacent and your hypotenuse, the negatives on the adjacent. You could have filled in the opposite by Pythagorean theorem. It should have been 3. Then you could have plugged into your formulas. So here's each of the formulas, the double angle formula written out, and then the values plugged in and simplified. So go ahead and check each of those. This tangent 2u1, remember, there's that nasty complex fraction. And I would tell you guys to identify, it's going to let me, oh, sorry, hold on. My smartboard is only half working today. It's quite a party. My computer's not crashing, my smartboard is. 2 times negative 3/4. You guys can keep checking. But for those of you that were like, ew, gross, how are we supposed to simplify? On the problem portion tomorrow, you need to be able to take something like this and simplify it to that multiple choice answer. So therefore, we would, as I showed you guys, identify the little trapped guys, right? I could multiply top and bottom by 64, 4 times 16, but can anybody figure out an easier or a simpler way? You don't have to multiply by 64. What could you multiply by? 32, they both go into 32, but what else did they both go into? 16. You could have just used 16 since 4 goes into it. As your trick, that would have reduced 1 and 4. 2 times 3 is 6, 6 times 4 is negative 24. That would be on top. On bottom, you would have had to distribute 16 times 1, 16. And as I come in here, what happens to the 16? And I just have, which is why the answer is negative 24 over 7. Just a quick reminder of simplifying. Number 42, you guys see down here, it's another formula backwards. It's another formula backwards. Now the nice thing is, on the problem portion tomorrow, are you going to have memorized this side of the formula to go backwards to? No. So when you're looking at problems tomorrow, and you're given something that looks confusing, you're not sure what to do with it, and they say simplify, for instance, can you look at not only the left side of the formula, but also the right sides of the formula? Do you guys know what I'm talking about? If we go to our formulas, where are the ones I told you to memorize? Well, here are some of them, right? If you have something like in a t-proof, or in an equation, you don't know what to do with it, and you have to somehow expand it, split it apart, simplify it, do math to it. Can you look on this side and try to plug in the other side 4 sine of 2x, or 4 sine squared of u, or 4 sine of u over 2? Can you look at this side and then plug in the other side? Yes. But can you also see this side and go backwards? Yeah. And so look at our example again. Our example that we were just checking a second ago gave you this. Square root of 1 plus, okay, is there anything that looks like square root of 1 plus cosine? Square roots are, square roots. 1 plus cosine. Hey, it looks like this guy. But as I'm looking at this guy, 1 plus cosine of, who's in the of spot? Because he's the guy that needs to go in there. I can go backwards in the formula too. So who's in the of spot? 4x. So what's going to go in the u spot? Oh, I hit the wrong one. Sorry, I apologize. I don't get it. Okay. So what's, if 4x is there, 4x needs to go here. And what's 4x over 2? 2x. Got it. That's exactly what the answer key shows. Now they put absolute value, that's them being super snazzy, basically saying that we're not sure where the positive one came from. We're not sure if it's positive or negative. That's not going to be something that you're tested on tomorrow as far as the absolute value, okay? But you can not only go forwards in the formulas, you can go backwards also. Number 62. Oh, did I have to skip that one? Okay, thank you. 62 was a sum to product, and those are the formulas that we get to skip, so forget him. Number 70, though. Whatever. Number 70, they gave you a formula, and you're supposed to be doing a t-proof, right? So decide to choose. You could have chosen this side. You could have made that 1 over sine, this one cosine over sine, tried to put together. You could have chosen this side, and when you went here to here to here to here, then you could have matched it to the formula, because 1 minus cosine of u over sine of u. Is that in our formulas? And the answer is yes. So you could have seen this side of the formula and made it that side. That's one thing you could do. Or you could have started with this side and transformed into that one, which is what the book chose to do. That's just what they chose. This guy to that guy. Now saying, hey, common denominators I can split apart. 1 divided by sine and cosine divided by sine. That guy's cosecant and that guy's cotangent. So you could have actually gone both ways. So you're going this way or that one. And remember, once again, guys, you shouldn't write it like that on the test tomorrow if you have a wrong answer, right? Shouldn't you have made that a T? You should have made that a T. Do we have any questions? I think that was the last even, right? Yes. Okay. Do we have any questions on 5.5 that we want to Number 11. Chris?
Oh wait, just it was number 11 also.
And number 11 also. AJ? 27. Let me get number 11 up so we can be peeking at it. Some of you might not fully remember, even though you should be able to look at your directions, what it was. 11, 27, and then Jackie was 33 too? 39?
And 33.
33. Okay. Let's go ahead and start with number 11, then 33, then 39. I think I might have left off. Was it 27? Okay, number 11 says find the exact solutions. What don't you like? This is actually the one we looked at partially yesterday, wasn't it? At the end of class. What was my hint to solve it? Do something to the 4x. You can make it 2x plus 2x or 2 times 2x, right? You can make it 2x plus 2x, or you can make it 2 times 2x. Let me go ahead and see if my computer won't freeze on me today when I'm trying to do this. Hopefully. Come in. Thank you. Come in. People who are doing the weird size, entertaining, but maybe not necessary. Okay, so we have number 11, we'll peek at him, solving 0 to 2 pi. We have number 27, AJ, that was your next one, right?
Yeah.
And then we had number 33 and 39. Okay. This one's direction is simplify, the first one's direction is solve, 33's direction is half angle formula,
And then 39's, I'm just doing it so I can remember. 39's direction is, ooh, picking the sign probably, huh? That one's tricky. All right, I'm going to go ahead and use all the directions on this guy. Okay, so number 11, first of all. Let's start there.
So my hint to you guys yesterday was, why are you so big? No wonder things are weird. You can make sine of 4x, sine of 2x plus 2x. What formula, guys? Let me expand this. Distribution! Let's distribute sin.
No.
No! What formula? Sine u cosine v. Good. Sine stays the
Same.
plus. Equals negative 2 sine 2x. Do these look similar?
Yeah.
Heck yeah, they do. Can't we just combine them? So 1 plus 1 is 2 out of the sine 2x cosine 2x's. Remember, multiplication can go either way, so those are like terms. Equals. I'm going to add this guy to the other side. And the reason being is because as soon as I get into the other side, first of all, I have it equal to 0, which is a good thing. When you can factor, is that equal to 0? What can you factor out that's in common? And you get it, cosine 2x plus 1. At that point, kiddos, you have to set each one equal to 0, which you've seen me model many times. Ultimately, in this one, you would get sine of 2x equals 0. Ultimately, on this one, when you set equal to 0 and subtract the 1, you get cosine 2x equals negative 1. At this point, we say, unit circle, 1, 2, 3, 0. Sine of 0 at 0. So we could say 0 and pi. I'm going to put a few more because some of you might remember that when you have this 2x, and we're going to have to divide everybody by 2 because we have to do the sign first, sine inverse both sides, then divide by 2. Even though something might have been too big to begin with, when I divide by 2, some of these answers that are too big actually end up fitting. Uh-oh, that one's 2 pi. He's too big. These were all good, 0 pi over 2, pi, and then 3 pi over 2. And when we would solve for this one, 2x is equal to cosine equals negative 1, 3, 2, 1. At 0, nope, cosine is positive 1 at 0. Negative 1 at pi. So it could be at pi, not 2 pi, 3 pi, not 4 pi, 5 pi. We can keep on going, but when we divide by 2, we say, wait a minute, we already have the answers. They're over there. Oh, that guy's too big. He's bigger than 2 pi. So I end up with my final answers of x equals 0, pi over 2. Well, it is 3 pi over 2. The next one, though, should be pi, and then 3 pi over 2. Number 27 was, I think, reduce or simplify to the first power of cosine using the power reducing properties. We showed yesterday that you can split a fourth up into squares, and then we talked about how you can use the power reducing formula for both. Help me out real quick, kiddos. The power reducing formula for cosine, it's 1 plus cosine double the argument, which would be 2 times that x over 2. And then I'd have 2 of them because they're being multiplied by each other. When I multiply, we're going to have to FOIL the top. We get that, and we're like, yay, we're done. We're not done. We made them simpler. No 4th degrees, no 3rd degrees, but we still have the squared. You guys double check my formula? Was it 1 plus?
Yes.
Okay, good. The problem is, though, this squared guy, he needs to get plugged in for 2. So we'd have 1 plus 2 cosine 2x. This guy needs his own power reducing formula. So we would do the 1 plus cosine double the argument, which would be 4x, all over 2, all over 4. You guys need to simplify the complex fraction, but then you're done. Number 33 gives us the half angle, or tells us to use the half angle, because here's the idea. You guys know if you're doing sine, cosine, tangent? You're doing something. I'll just say
All
sine.
3.
Cool, so let's just start with sine. 75, not in the unit circle. But isn't p half of 150? Use the half angle formula because 150 is a unit circle I can do. 150 is a unit circle I can do. So use the half argument u over 2 formula for that. Last but not least, number 39. Using the half angle, who is letting kids out early? That's annoying. Using the half angle formulas. Determine the quadrant in which u over 2 lies and find the exact value of, okay, I know the little slashes are missing. Let's just do sine of u over 2. You guys have a formula for sine of u over 2, right? Isn't it plus or minus the square root of 1 minus cosine? Is it cosine of x? All over 2?
Yeah.
Okay, Sedilio. When given a ratio, make a triangle. They tell us this needs to be in, this is the fourth quadrant, so over here. And I know tangent gives me opposite and adjacent. With Pythagorean, you should be able to find 13 is your hypotenuse. So I can look at this guy and I can say, hey, I want the cosine of him, and I can actually plug it in pretty quickly. The dilemma is, after you get cosine, adjacent over hypotenuse, which would be 12 over 13. After I get cosine, I still have to figure out, well, A, I have to simplify my complex fraction by multiplying top and bottom by 13. So first I'd have to do that, which would be 13 minus 12 all over 2, which ends up being the square root of 1 over 2. So here's a dilemma. I also have to choose, so sad, it's test tomorrow, and yet we're packing up like 2 minutes early. I know some of you just left. Oh well. I want you guys to want to do well. We have to choose plus or minus. If this is u, where on earth would his half angle be? Is it in quadrant 4, the half of this angle? No, it doesn't make sense. Is it in quadrant 3, quadrant 2? It's hard, right? But if you think about it, isn't any angle that we would choose, what's something in here, 330? If I already cut 330 in half, what would it be? 115. If I was to take any angle and cut it in half, guess where all of them end up? Second quadrant. Question, what sign does sine have in the second quadrant?
Positive.
All students. If it was a cosine one, what would you choose? Negative. If it was a tangent one, negative as well. So that's what it means by choose. I'm really glad we got to totally finish up section 5.5 questions and we were able to go through those. What did we not get to go over? Review questions. But who's here today during lunch? Not 7th period, but after school today? Me. You can ask the questions if you need to. Bring your notes tomorrow. Bring your homework files tomorrow. The 5152 quiz. We're not turning in corrections today because I want you to be able to study them for tomorrow, but we'll be turning them in tomorrow. So having your quiz corrections ready and your notes and your styles. The quiz corrections, I'm just going to have you guys staple on the back of the quiz because some people will just correct on the quiz itself. So I'll go looking for them no matter what. So just staple those corrections if you need to on the back. Have everything ready to turn in tomorrow. If you borrowed a book, please give it back. I'll see you guys later. Did I miss the corrections? You guys? Oh, yeah. You need to staple the corrections, but they're not due until the test tomorrow.
Abby, can you wait like 2 seconds?
You don't need to do a separate paper, lady. It's just a different color pen on paper if you need to make a change.
I actually that is a C. I did. Working today. I need your what's it called? I need your Spanish workbook. It's like
But in a way, you busted out, Jordan. Like instead of a full year worth of homework.
Yeah.
It's good and bad. It's good and bad. But is it a C